Now we will understand about the some basic things of superintendent and receiver. That is largely I will say that the modernized receiver section that radio engineering have that ever had. And here you can see that there's something some math type situation that has been drawn here. First of all, select an AM station that has been 640 kilohertz. That means the receiving frequency will be 640 kilohertz. The station is designed for the certain frequency that what kind of frequency they will take, and tune the RF amplifier to the lower end of the AM band. That means the RF stage that will tune it is the lower end of the AM band. That means the amplitude modulation band, the lower end of the amplitude modulation band, that will RF amplifier should have to be tuned in that kind of sections. In previous lectures, I have told you some oscillators and some amplifier sections. The tuning section is the known as the tank circuit, so that should have to be tuned, as well as to have a good coordination between the AM band and the receiving frequency. Third point of view is that they tune the local oscillator to a predetermined frequency of 1095 kilohertz. As you can see here, there is a local oscillator, and this local oscillator frequency is quite higher than the receiving frequency, that means the signal frequency. And these two frequencies are now been mixed, and after mixing that we will get the FO minus F naught, FO minus Fs. First of all, you can get the 195 kilohertz and 640 have been mixed here. This produces the following signals at the output of the mixer circuit. Okay. Now, what is the local oscillator frequency? That is the 1095 kilohertz. What is the AM station carrier frequency? The carrier frequency is the signal frequency, that means 640 kilohertz. And what is the difference frequency between these two? That will go to the IF section. That is the FO minus Fs. That we can calculate it by that, get the 455 kilohertz, and that is the intermediate frequency. That is the intermediate frequency that should have to be amplified in the next stage. So the 1735 kilohertz is the sum of the frequencies. Okay, if we sum up the frequency after mixing, that is the 1735 kilohertz. So these signals are then fed into the IF amplifier. Because of its narrow bandwidth, the IF amplifier rejects all other frequencies but 455 kilohertz. Okay, at IF frequency, at the block of the IF amplifier, when the signals have been fed into the input section, thus they have the narrow bandwidth, so they will just take this type of IF amplifier they will take just 455 kilohertz. That means the difference between these two, and rejects all other frequencies out of that. Okay, now coming back to the RF section and the characteristics. So the RF section is a tunable circuit connected with the antenna terminals. It is there to select the wanted frequency and reject some of the unwanted frequency. That means this section is what can we say? It's like a filter that what type of frequency we will take and what type of frequency we will reject. The reasons behind the functions of the RF amplifier are the greater gain, improved image frequency rejection, improved signal to noise ratio, improved rejection of adjacent unwanted signals, that is better selectivity, better coupling of the receiver to the antenna, prevention of unwanted high frequencies from entering the mixer stage, prevention of re-radiation of the local oscillator through the antenna of the receiver. Now you can see that is the RF section characteristics that I have told you before, that there might be and there will be and there should have to be tank circuit. That you can see here, there is a tank circuit in the receiving section where the antenna is connected with this tapping of the notice that will not be the transformer section, that will be inductor section, that will be tapping with the base of the transistor that can be seen, and you can see here that is the tank option, the tank circuit, and that is also the tank circuit. So both tank circuits are on the active sides. And how can we say that it's a tank circuit? Either sides have the capacitor and inductor, and that is going to be the key feature of the tank circuit and the tuning part of this circuitry. And there is a gain control as known as the RF gain. There is a variable resistor, that means that will vary the gain of the amplifier section. So now that is what is the sensitivity. So that is the very much important thing that you have to know. There is a curve that I have that I have shown here. There is a sensitivity curve. That means because of the frequency, these curves, when the frequency get greater, the value is getting much higher. The sensitivity is quite high, and the unit of the sensitivity is a microvolt. So that tells us the truth that the how much frequency that enters into the circuit, and for that response how much output voltage will come out of it with respect to the input voltage, that is the sensitivity. So sensitivity of a radio receiver is its ability to amplify weak signals. That means that has some ability to amplify the weak signals. That means the section of the quality measurement of an amplifier, that how weak signals can be amplified. It is often defined in terms of the voltage that might be applied to the receiver input terminals to give a standard output power. Now the selectivity, the most important part. The selectivity is of a receiver is its ability to reject unwanted signals. That can be shown here. That generator detuning of the kilohertz and the receiver tuned to 950 kilohertz. So at the point of 950 kilohertz, the attenuation should have to be low. There will be less attenuation in the not this corner frequency, in the center frequency, and that's going to be the selectivity. The selectivity of a receiver is the ability to reject unwanted signals. That means after rejecting that, we can get the better amplification, and also have a good that we will get the desired signals right there. Now, what is the image frequency? The image frequency is an undesired input frequency equal to the station frequency plus or minus twice the intermediate frequency. Now I have to tell one thing in the basic of the image frequency. Some of the people understand that image frequency means that some image will go through to some signals and we will see some images. That's not the case on the radio frequency. The image frequencies means like that whenever you see onto the mirror your face, that is the image of your face that you can see here. So the image frequency means the same kind of a frequency that creates on the either side of the axis. That means if we take the local oscillator frequency, the high frequency in the center frequency. So after calculating the IF frequency is between the it is between the range of something from the high frequency and low frequency. That means that is not only the difference, but also from the narrow band we will take the difference, but it will range between the addition and the difference. That means we have to first of all FO plus FS, and then we have to take FO minus FS. So image frequency is like that. It's one kind of a folding frequency. In two sides there are two frequencies. One is image frequency and other is the desired station frequency. Whether we could take the difference between Fs minus Fo, the difference of these two frequencies are the desired frequency in a narrow band situation, and for the better quality. On the other hand, on the same surface, on the same type of what can I say, on the same type of difference, not that is not the difference, the same type of distance between the local oscillator frequency and the image frequency are the same as the desired station frequency and the local oscillator frequency. Just like that, that is the image that has been created on the other side of the local oscillator frequency. That means the local oscillator frequency is the mirror side. That means that is symmetrical between the y-axis. So we can write F image is equal to Fs plus twice F IF image frequency, and F image can be written as also Fs minus twice IF. If Fs is greater than Fo, or if Fo is greater than, that means the plus sign will come forward. So that's all for now for the image frequency. But there are some station frequencies, the Fs, the intermediate frequency 455, the LO local oscillator 195 kilohertz, and you will definitely get, after giving the value, you will get the image frequency right there.